Welcome to Brain Vision.
So to find the frequency and time period from mass and spring constant, we can use the direct formula. So for time period, it's t equals to 2 pi square root of m over k. And from there, if we use the given numbers, we have 2 pi square root of m, which is 0.885 kg. And we divide that by the spring constant, which is 184 Newton per meter. So that's equal to 0.4358 second, or if we approximate it, this is 0.436 second. So now for the frequency, it's just 1 over the time period. So that's going to be 1 divided by 0.4358 second, which is equal to 2.29 hertz. Now for part B, the initial speed is the maximum speed, and that can be used to find the amplitude. So Vmax is equal to a square root of k by m. And from there, if we solve for the amplitude, that's Vmax square root of m by k. Now using the given numbers, we have 2.26 meter per second. Then for the mass, it's 0.885 kg. And we divide that by 184 Newton per meter. So that's equal to 0.1567 meter, or that's roughly equal to 0.157 meter. For part C, the maximum acceleration can be found from the mass, spring constant, and the amplitude. So A max for the maximum acceleration, that's A times spring constant by m. So that's 0.1567 meter times the spring constant, 184 Newton per meter, and we divide that by the mass, which is 0.885 kg, which is equal to 32.6 meter per second squared. For part D, the maximum energy is the kinetic energy that the object has when that's at the equilibrium position. So E is equal to half of mv max squared. So that's half of 0.885 kg times v squared, which is 2.26 meter per second squared, which is equal to 2.2601 joule, or 2.26 joule. Now for the final part, we can use the conservation of mechanical energy for the oscillator. So noting that we found the total energy in part D, and that another expression for the total energy, E total, is equal to half of k a squared. So we can write E is equal to half k x squared plus half mv squared, and that's equal to half of k a squared. So from there, we have half of k, where x is 0.4a, and then there's a square, plus the kinetic energy, that's equal to half of k a squared. Now from there, we can solve for the kinetic energy. So kinetic energy is equal to half of k a squared minus half of k 0.4a, and then there's a square, so that is equal to half of k a squared 1 minus 0.4 squared, which is equal to e total times 0.84. Or now we know that E total is 2.2601 joule, and times 8.84 gives us 1.9 joules. Right, thanks for watching.